All right, so to review scatter plots in class, we did an activity to get this data. Since you were not in class, this is just data that I have that I want you to copy down and we're going to use for the sake of this video. But this is all just a practice at the scatter plot functions that we looked at last class. So if you'll just copy down this data, this is what we're going to use in order to make our graphs. So I'd pause the video because I'm going to just keep going for the sake of time. So what we're going to do if we're going to make our scatter plot is we're going to have to type this data into our list 1 and list 2. So we'll hit stat and then edit, and then we'll type list length into L1 and average time into L2. So if I go ahead and go stat edit, I'm going to clear all my current lists. Okay, and then I'll type in the corresponding 9 was with 6.3, 8 was with 5.82, 7 was with 11, 6 was with 4.28, 3 was with 1.2, that's a 9. Sorry if that's an ugly looking 9. That's a 9. That's 8.66. Okay, so we've typed, sorry, that's also an 8. It's not very pretty, but it is an 8. So we typed in our values into our list 1 and list 2 so we can make our scatter plot. Before we do that, we can go ahead and figure out what our equation would be and put our line in our graph as well. So to do that, to find these values, we go to stat, then to calc, and we'll pick number 4, which is our linear regression, LINREG. So stat over to calc number 4. Oops, I made it mad. List 1 and list 2 is where we put our data. So we'll go ahead and hit calculate. So my A value is 1.137. My B value is negative 1.399. And R here is 0.804. So when I write my equation, remember this is AX plus B. So I'd write A first, 1.137x plus negative 1.399. So now that we have this, we'll go ahead and type it in to our y equals. If we press y equals, we'll type in that y value, x, I'll just put minus. And then now that it'll graph that and my scatter plot, let's make sure my scatter plot's set up correctly. So if I hit second stat plot, it's on this. I need this to be out of list 2. So I'll hit second 2. And now it should be ready to graph. So if I hit zoom 9, there's my scatter plot. So we'll go ahead and sketch that. So this was my list length. And this was my average time in seconds. And it just kind of looks like my line went like this, kind of. That's the estimate of my line. Great. Yeah, so if we hit second, so first we go to y equals. After this, we're going to go to y equals and type in that line. And then we'll go to second y equals and make sure our plot is on. And it's running from list 1 and list 2. and then we can make our graph. And then always we can hit zoom 9 to go ahead and make it so it only shows us the picture that we want. Okay, so then next we would sketch our residual plot. So first we need to figure out what our residuals are. So we'll do stat, edit. We're going to go over to list 3 and hit second stat. So we'll go over to list 3 and hover over it. Hit second stat and then go to number 7, which is our residual. When we hit enter twice, all of our residuals then show up for us. So then after this, we're going to want to go to y equals and clear it. So go to y equals and clear that off. And then we have to go to our second y equals and make sure it's going from list 1 and list 3 now. Remember, our residuals are now in list 3. So we'll hit second stat. Make sure it's all the same information except we want this to come out of list 3. So we hit second 3 and that changes that to list 3. And then we can hit zoom 9 to show our picture. So we would draw here. We forgot. There would be our residual. So this is still our average time. This line is now our y equals 1.137x minus 1.399. Remember, a residual is just simply taking this line and now making it the x-axis and showing the difference, how much your y's differ from that line of best fit that we made. Okay, so then we're going to go ahead and answer some questions on the back. So it says, discuss how good of a fit this line is for our data set. If we remember, our R value is 0.804. So there's a positive correlation . However, the data is not very linear, right? If we think about it, if we look at our picture here, this doesn't really have a line tendency. It's kind of like a stair step almost. So I wouldn't really say that a line is the best fit for this data. It's not terrible because this is a 0.8, but I wouldn't say that it's great. So then if we interpret the meaning of our slope, again, we'll have to go copy down our equation. So 1.137x minus, and it was 1.399 was our line of best fit that we're using. So our slope is 1.137. We'll write it over 1. So our y value was our time in seconds, and our x value was our list length. So as our list increased by 1, the amount of time it took also increased by 1. So as our list increased by 1, the time it took also increased by about 1, right? We have 1.137, which is pretty close to 1. All right, so then if we wanted to estimate how long it would take a person to say 15 words, again, we just use this equation. And then if 15 words was our x value, so we're going to make x 15. So on my calculator, I would do 1.137 times 15 minus 1.399. So it would take about 15.665 seconds And then if they want to know how many words a person could say in 3 seconds, that's now my y value. So then I'm going to solve for x. So I would have 3, I'd add 1.399 to it, and then I would divide by 1.137. So it'd take about 3.86 seconds to read a list, or 3.7 seconds. No. My list has 3.87, so roughly 4 words on it. This one would have to make more sense, right? You're not going to have 3.87 of a word. So we'd round that up to 4. All right, so we're going to do the same thing. I'm going to pause the video, write out some data, and then have you copy that down. Again, this is just data we collected in class that I'm using for the sake of this video. All right, so here's the data that we collected. I'm strongly going to advise you to pause the video. Try to see if you can do 106 and 107 on your own. But I'll go over it as well if you need some more practice with making those scatter plots and such. So copy down that data. Again, try pausing the video, see how much of the information from 106, 107 you can do, and then I'm going to go over the answers now. So first, I need to type these values into my list 1 and list 2. So I go to Stat, Edit. I'm going to clear all of these first so I don't get confused of what's what. And then I'm going to type all these into list 1 and all of these into list 2. All right. So I think I'm good. I'm just kind of double checking really quickly that I typed these in correctly. You always want to make sure your data is right, because if it's off even by a little bit, it's going to change all your numbers, and it's kind of hard to tell where the mistake is when all your numbers are different. So we typed everything into list 1 and list 2. So now let's go ahead and calculate our y and our r. So we'll go Stat over to Calc and number 4. Our information's in list 1 and list 2. So I get that A is 1.0648, B is negative 0.78, and my R value is 0.5037. So I can make my line from this 1.0648x minus 0.78. If I want more decimals, I can carry 26 with me. Yeah, remember we did Stat, Edit, typed this into list 1 and list 2. Then we hit Stat, go over to Calc, and then we pick number 4, which is our linear regression. So now we're ready to graph. So to do that, we're going to go to y equals, and we'll type in our line. So I'll go to y equals, I'll type in this value here, 1.0648x minus 0.7826. And then I'm going to go to second y equals, and I'm going to turn my plot on, make sure it's on Scatterplot and that it's coming from list 1 and list 2. So I want to change that, I hit second 2 to make it come from list 2. So then I can hit zoom 9, and there's my picture. So I'll go ahead and sketch that. Again, we're not getting super specific. All right, list length, average time in seconds, And then I got my line looking like this. And I'm just sketching out the points that I have. Just a rough estimate of what that looks like. So that matches my scatter plot enough. All right, so then let's go ahead and look at page 107. So now we're going to make our residual. So remember, that's when we have to go to Stat, Edit, and we're going to go to List 3. So I'll go Stat, Edit, over to List 3, and then we hit Second Stat and pick number 7, which is our residual. So Second Stat, number 7, hit Enter again, and there's all our residual data. Then we want to clear our y equals. So I'll go to y equals and I'll clear that off. Then I want to go to second y equals and make sure it's from list 1 and list 3. So second y equals, and we want to pull from list 1 and list 3 now. So second 3, we'll change that to list 3. So when I hit zoom 9, this would be my residual. So again, this line is the line of my equation. So y equals 1.0648x minus 0.7826. This is my average time. And it looks like that is my residual. So then if we want to talk about how good of a fit this data is, remember your R value is 0.5037. So that's a positive correlation. However, this number is not great. This number is low, so this is not a good fit for a line. Right? This is worse than the last one. So this saying that this line of best fit is really not the best fit for this graph. It really wouldn't do much in describing what's happening because a line doesn't really describe it very well. This correlation is way too low to say that a line's a good fit for it. So then are the results from the matching and not matching experiment what you expected? So if you think about your data in this sense, it's taking you longer. It's taking you more time to. It's kind of a hard problem because we didn't actually do the activity, but it does take longer to do a non-matching list than it does a matching list. And we would expect that because it's easier to read when lists match than when they don't. But for the sake of this, that question doesn't really apply since we didn't do the activity. But hopefully that was a good review on how we make our scatter plots and our residual plots and kind of what we can do with that information.